Today, I'm going to present about a high-power semiconductor diode that are commonly used in high-frequency microwave electronic devices, which is the IMPACT diode. Hi, my name is Madesh Kumar Nalikichai and then enrolled in course SIF2017. Let's see what is an IMPACT diode. Now, the abbreviation for the IMPACT is Impact Ionization Avalanche Transit Time. Now, this diode is a high-power semiconductor diode that are utilized for microwave applications. It is used as an oscillator and amplifier at microwave frequency ranging from 3 to 100 GHz. It possesses a negative resistance characteristic, so it acts as an oscillator to generate signals. This diode is a reverse bias diode, and the avalanche condition is the basis of its operation. Now here we can see the schematic diagram of the impact diode. You can see the avalanche region and also the drift region. Historical background about the discovery and concept of impact diode. The original idea for the impact diode was first proposed by William Shockley in 1954 in his paper titled Negative Resistance Arising from Transit Time in Semiconductor. In his paper, he developed the concept for creating a negative resistance using a transit time delay mechanism. In his proposal, the method of injection for the carriers was forward bias PN junction. Here is the picture of William Shockley. The idea later was further developed in 1958 by W. T. Reed, proposed his P plus and N plus diode structure, which later called the Reed diode in his paper titled Proposed High Frequency Negative Resistant Diode. The paper analyzes a proposed semiconductor designed to operate as an oscillator when mounted in a suitable microwave cavity. The diode uses avalanche multiplication as the injection mechanism. The first practical operating diode were made and first oscillations were observed in 1965, where the diode used for demonstration fabricated using silicon and had a P plus N structure. Later, the operation of the Reed diode was demonstrated. In 1966, a pin diode was demonstrated to work. This pin diode is similar to the one that we are using today, the IMPACT diode. Working principle of IMPACT diode. As you can see from the picture, IMPACT diode has a very similar IV characteristic to any other form of PN junction diode. It conducts in the forward direction once the terminal voltage has been reached. In the reverse direction, it blocks the current flow until the diode breakdown voltage is reached. In this point, avalanche breakdown occurs and the current flows in the reverse direction. For the operation as a microwave signal generator, IMPACT diode is operated under reverse bias condition. These are set so that the avalanche breakdown occurs. It occurs in the region very close to P plus junction, where it is a heavily doped P region. The electric field in the PN junction is very high as the voltage appears across the very narrow gap, creating a high potential gradient. This causes the carriers accelerate very quickly as they require sufficient energy, which result in electron hole pairing by collision with crystal lattice and other carriers. For this breakdown, only a certain voltage is applied to the junction, and below this potential, the carrier does not accelerate sufficiently. Operation in IMPACT diode. Here we can see the diode structure and also the carrier charge movement within an IMPACT diode. An IMPACT diode consists of two areas, the avalanche region or the injection region and also the drift region. In the avalanche region, it creates carrier which may either holes or electrons, whereas in the drift region, the carriers move across the diode, taking a certain amount of time dependent upon its thickness. Once the carriers have been generated, the device relies on negative resistance to generate and sustain an oscillation. The effect does not occur in the device at DC, but instead here it is an AC effect that is brought about by phase differences that are seen at frequency of operation. When a when an AC signal is applied, the current peaks are found to be 180-degree out of phase with the voltage, which results from two delays which occur in the device: injection delay and transit time delay as the current carriers migrate or drift across the device. The voltage applied to the impact diode has mean value where it is on the verge of avalanche breakdown. As you can see from the impact diode voltage and current waveforms, the voltage varies as a sine wave, but the generation of the carriers does not occur in unison with the voltage variation. It might be expected that it will occur at peak voltage, as the generation of carriers is not only a function of the electric field but also as the number of carriers that are already in existence. The number of carrier increase as the electric field increase. Then even after the electric field has reached its peak, the number of carriers still continues to grow as the result of the number of carriers already in their existence. This continues until the field falls below a critical value when the number of carriers starts to fall. As a result, there is a phase lag so that the current is about 90-degree behind the voltage known as the injection phase delay. When the electrons move across the N plus region, an external current is seen, and this occurs in peaks resulting in repetitive waveform. The application of impact diode. Impact diodes are used where compact, cost-effective means of generating microwave power required. These diodes are usually used in parametric amplifiers, microwave oscillators, or microwave generators. It also used in telecommunication transmitter like the dish here, into the alarm system, and also receivers. Here are some example picture of the application of impact diode. Is the into the alarm system and also the RF detector.